So we have some example problems. Let's say I have the proportion x over 3 is equal to 2 over 5. Then 5 times x is equal to what? Well, I want to recognize here that 5x is coming from multiplying the extremes. 5 times x. These are the two extremes of this proportion. So that will be equal to the multiplication of the means, in fact. So it's equal to 3 times 2, which is, of course, 6. Okay. Here's a proportion expressed with the ratios in a different form, but it's really the same thing as up here. A to 3 is the same as saying A over 3, and 7 to 4 is same as saying 7 over 4. So 4 times A, well, this is now the same situation as here. I have 4 times A, those are the extremes being multiplied. 3 times 7 then will be what this is equal to. So we have 21. If A over 4 equals B over 7, then A over B equals blank over blank. Okay, here in the original given statement, A was one of the extremes and B is one of the means. And B was the second mean. It was the mean from the second ratio. But now B has been moved to being the first mean. Okay, it's been moved to the place where this 4 is. So the property that they're invoking here is switching the means. We're switching the position of the means. So if I switch B, then that means 4 has to take its place, and 7 and A stay where they are. So this is the same as saying A over B is equal to 4 over 7 once I swap B and 4. Here, they are using property 4, okay, where I add the denominator to the numerator. So if x over 2 is equal to y over 3, then x plus 2 is going to be equal to y plus 3 over 3. Okay, here are some other proportions, okay, where we have an unknown. If I want to solve for x, how will we do this? Well, again, cross multiplication is our best friend. So if I cross multiply these, 7 times 4x plus 6, be careful, make sure that you're multiplying everything in this term by everything in this term, and not just 7 times 4x and then forgetting to multiply the 6. You may have to make sure that you distribute, is equal to 9 times 6x minus 4. Okay, and then I expand these. 28x plus 42 is equal to 54 minus, oops, excuse me, 54x minus 36. Let's subtract the 28x, and let's add the 36. So 54 minus 28 is 26. 42 and 36 is 78. When I divide this by 26, I get 3. Okay, so I found x for this situation. Again, if you're not sure, take x back here, plug it in, and see if the proportion holds. 6 times 3 is 18, minus 4 is 14, so I get 7 over 14 here. 4 times 3 is 12, plus 6 is 18. 9 over 18 here. Is this true? Yes. So this is the correct answer. All right, here's a little more complicated example, but again, we're still just going to cross multiply things. X times x plus 5 times 5. Is equal to 9 times 4x plus 4. Okay, here I have x times x. So actually I'm going to distribute inside the parentheses first. And this is the only wrinkle in this problem that makes it more difficult than the previous one, is I'm going to have a quadratic. I'm going to have an x squared term here. X times x is x squared. X times 5 is 5x. And I multiply all of that by 5. Here, 9 times 4 is 36, and 9 times 4 is 36. So I have 5x squared plus 25x equals 36x plus 36. Now again, to solve a quadratic, we can either use the quadratic formula or we can try to factor it. But in both cases, we're going to need everything over on the same side and everything set equal to 0. So I'm going to want to move both of these terms. So I end with, actually let's do this here, 5x squared minus 11x minus 36 equals 0. Okay, if you can't find a factoring for this, then just plug it into the quadratic formula. But here there actually is a factoring. I can do 5x. It's a way to unfoil this. Okay, I'll loif it. And factors of 36 that when I multiply it by 5 and 1 will add to negative 11. Okay, it ends up being, let's see, how did this work out? It's 9 and 4. I need the 4 here, and I need 9 here, and I need this to be positive. Okay, so we can check that we've done this correctly. 5x times x is 5x squared minus 20x plus 9x. Okay, that gives us negative 11x, and then 9 times negative 4 is negative 36. Okay, so this is the correct factoring. And then when I set each of these equal to 0, then I get x equals 4 from the second equation, and I get negative 9, and then divide by 5, so I get x is negative 9 over 5. So these are my two. There are actually two solutions here which will make this proportion valid. It could be x is equal to 4 or x is equal to negative 9/5. Both of those will make this proportion legitimate. All right, this is geometry though. So really we're more interested in shapes and things and how we can use proportionality with shapes. So here's an example of this. We have here a triangle with a trapezoid or something inside of it, so it's divided into two. And we're told that we're operating based on this information that's given to us. Okay, there is a proportion between this ratio, KR to RT, so this length to this length, and KS to SU, this segment to this segment. Okay, there's proportionality between those. And so if I am given certain information, I'm going to try to find the other pieces of this that I don't currently know. So if KR is 12 and RT is 9 in this first instance, then that means my proportion here is 12 over 9. And I'm told that KS is 16, so that's this term. But I don't know what SU is. But that's okay, because setting up this proportion now, I have an algebraic equation with only one unknown. So I can cross multiply and I can solve for this. Okay, and if we do that, and we do the algebra and we solve for SU, we'll find that SU is 12. KT is just the total length here. So I already know this is 12 and 9, so KT is just, I'm going to use the segment addition postulate and add those. 12 and 9 gives me 21. And KU likewise is just the total length here between KS and SU, so 16 and 12 is 28. Okay, so we've solved for this information. Let's say now instead we are given only that this is, actually let's go ahead and do this in a different color so we can keep this straighter. This is 16. I don't know RT now. Okay, this is unknown. SU is 10, and the total length here, KU is 30. Okay, this is a little trickier, and we're going to have to work a little bit backwards this time. The total is 30 here. SU is 10, so that means that this is 30 minus 10. KS is going to be 20 units long. And now I can use that again to set up a proportion. So I can say that 20 to 10, KS to SU, is equal to 16 to whatever RT is, This is what I don't know here. Okay, again, I will cross multiply these, and I get that RT is 8. So again, the total here now, 16 plus 8, is 24. Okay, so proportions are actually very powerful in certain situations in geometry. Okay, these get trickier as we go. So now we have 3 pieces of information. KT is, let's switch colors here. Let's do purple. KT is 12. So we're told this total length. And KS is 10 now, and SU is 5. So this total length is 15. So we already found KU. Okay, but we don't know either of these pieces. So this is a little bit more difficult to see the trick here. What is the relationship between KR and RT and this total length? Well, if I add those, I get the total. So think of it this way. Okay, so I was struggling to explain this well last time on this last problem. So we have a situation where we have this shape and we know these segment lengths and the total here and the total only on this side. What we're going to end up using actually is this property of proportions. Okay, this idea that I can add the denominator to the numerator on each side and still keep a valid proportion. So let's see how that is. We kind of have to come back to the original given that we were told to work with in this problem. KR to RT is equal to KS to SU. Those two ratios are the same. So if I start from this point, it's a little bit easier to see how that property, that fourth property of proportions, comes into play. Because what I'm really interested in here, or what I know about this side, is this total length. And this total length, as I said before, is KT, which is equal to KR plus RT. And KR plus RT, well, if I use that fourth property of proportions on this original proportion, then I will be adding this to the numerator. And I'm going to create exactly that in this new proportion that I'm coming up with. So if I do that here, then I have to add this denominator to this numerator. So I have to do KS plus SU over SU. And KR plus RT is just this whole side length, KT, so I can replace that. I can substitute. So this proportion is also valid. KT over RT, KS and SU is KU. It's equal to KU over SU. All right, and this is what I'm going to be able to use to actually find these unknown parts that I was originally looking for. So let's go ahead and plug these in now. So KT is this whole length of 12. RT is what I want. That's what I don't know. Let's just leave it as RT rather than calling it X. KU is this whole length, 15. SU is 5. So this should make sense also if you think about it. So this piece on this side compared to this whole side length is proportional to this piece on this side compared to this whole side length. Okay, that's more or less what we're saying here. So again, if I cross multiply this, I get 60, and then when I divide by 15, I'm going to get 4. So RT is going to be 4, and then if this is 12 and this is 4, then this means this has to be the difference between those. So this will be 8. So if we come back to our chart now, we can fill in those values. So RT will be 4, and KR will be 8. Okay, and final example. This time we're given RT is 9, and KT is 36. So we have this information instead. That's 9 and that's 36. And we're also told that KU is 48. So we know that this side is 48, but we don't know any of these. Well, we've already created the proportions that we will need here in the last problem. Okay, if we have this same position, if we get to this same step in the process as we did in the previous one, we still have enough here to fill in 3 of the 4 terms in this proportion. That's kind of always what you're shooting for. If you have 3 out of the 4, then you only have 1 unknown and you can solve for that. So here I have from this form that I converted this to using the properties of proportions, I have 36 to 9 from KT and RT being compared, and then 48 to SU, which is one of my things that that is unknown, okay, that I'm actually looking to try to find. So here now I can just cross multiply again and solve for SU, and I'll skip all that algebra, but when you do that, you'll find that SU is 12. Okay, again, if you're not sure if you did this correctly, you can always check. So, 36 divided by 9 is 4, 48 divided by 12 is also 4, okay? So that's going to be the correct answer. So if this is 12 and this is 48, then that means that this remainder, this difference has to be 36. And over here, if this is 36 and this is 9, then this difference is going to be, this remaining segment is going to be 27. So we can come back and fill in our chart now. So KR was 27, SU was 12, and KS was 36. Okay, so this is an example of how powerful proportions can be and how we can use them to solve for unknown quantities in geometric figures.